Hello, my name is Steve Bowler, and in this video we're going to be taking a look at RIP version 2. Specifically within RIP version 2, we're going to be taking a look at RIP version 2 updates. So we all know that RIP version 2 sends updates to multicast address of 224.0.0.9 by default. Now legacy RIP, or RIP version 1, is going to broadcast its updates to its peers. So as you can see here, we have two different types of updates already that we're dealing with. The default for RIP version 2 is multicast to the 224.0.0.9 IP address, and RIP version 1 is going to broadcast its updates out. Now there's another type of update, ways that we can pass updates between RIP version 2 neighbors, and that's by Unicast. So let's go ahead and just put all the types down here. So we have multicast, we have broadcast, and that's the RIP version 1 default. And then we also have another option we can do, which is Unicast. So what we're going to do in this video, we're going to be taking a look at those types of how to get RIP version 2 updates to our neighbors. And we're also going to take a look at possibly doing a feature to where in a lab or a test, you get an option to advertise a network into RIP, but to not use the network command. So what we're going to do here, we'll have a couple networks on router 1. So we'll have loopback 0 will be 10.0.0.0/24, and then we'll also have a loopback 0 on router 2. And this network will be 20.0.0.0/24. We're going to advertise these networks into RIP, and what we're going to do now, we're just going to be taking a look at the default behavior of RIP if we enable RIP on a broadcast network type, and we're going to take a look and see the default type of RIP version 2 update. So we should see it sending updates on this multicast address of 224.0.0.9. So give me a second here. I'm going to go ahead and get the default configuration in these two routers set up. As you can see, these routers are going to be on the segment, the 12 network. So 192.168.12.0/24. Okay, so now that I have the two routers up here, let's go ahead and get into router 1. And we'll go ahead and set up the interface to router 2 here, which is fast Ethernet 00. Give it 192.168.12.1 IP address. Go ahead and do a no shut there. Then on router 2 we'll do the same thing. Interface pointing to router 1. We'll get into it, give it the IP address of 192.168.12.2/24, no shut. And then while we're on router 2, let's go ahead into loopback 0, and we'll do a 20.0.0.1/24. And then we'll go ahead and configure router 1's loopback 0 interface, which is going to be 10.0.0.1/24. Okay, let's verify we have reachability across the fast Ethernet connection here. So 192.168.12.1 is going to be from router 2 to router 1. And we have connectivity here. Okay, so let's go ahead and get RIP configured. And what we'll do is we'll just do a debug IP RIP. And we'll do this on both the routers here. And then we'll just go through this. We'll go through all the different ways of getting the RIP version 2 updates to our peer. First one, we'll just look at the default configuration when we enable RIP version 2. So by default here on router 1, if I just do a router RIP, and then do a no auto summary, because we do not want to. We want to disable summarization at the classful network boundary. So we're going to allow subnet mask information to go between, to work within RIP version 2. Also, we're going to do version 2 is going to be what version of RIP we're going to be running here. So let's go to router 2. Actually, let's try this. Let's see if we can mix version 1 with 2. And you go ahead and place your bets and see what you think here. We'll just do network 192.168.12.0 on router. Now you can see here, this is exactly what we were talking about with RIP version 1. On router 2, actually, let me do this before I get in here and forget. Let's do no auto summary. So again, router 2 is running RIP version 1. Router 1 is running version 2. We haven't put a network up yet here. Let's go ahead and do that for router 1. So we'll do network 192.168.12.0. And I should start sending updates. Here we go. And now what we can see here is that we are seeing two different types of RIP version 2 updates already. We are seeing legacy RIP version 1. We are seeing updates being sent to our updates using broadcast, which is all 255s, and with version 2 over here on router 1, we are seeing updates to the multicast address of 224.0.0.9. So now if I go on to router 2 here, and in this example we'll be safe if I put in the network, the 20 network, because we don't have it running anywhere else here in this simple lab, so we don't have to worry about summarization in this lab. So we do a network 20.0.0.0, advertise our loopback 0 interface on router 2 into RIP. So now what you can see here is we're getting a interesting update in the debug. It says ignored version 1 packet from 192.168.12.2 illegal version. So obviously here version 1 and 2 not compatible. If I do a show IP protocol on router 2, it's not seeing a gateway, so we're not seeing a peer. On router 1, if I do a show IP protocol, same thing, no peer. We're sending and receiving just version 2 on the Fast Ethernet interface here. Router 2, we're sending and receiving 1. We're receiving updates for version 2, but we're only sending version 1. However, on router 1, we're only receiving and sending version 2, so this is not going to be compatible here. What you're going to see here, though, is if on router 1, if we go in here, if we do a router RIP, then we do a network, and then we advertise our loopback 0 here into RIP, we should see here we are. See? It's working. Router 2 is actually receiving version 2 updates. As you can see here, when we just did a router RIP, we put it in RIP version 1, we're sending version 1, receiving version 1 and version 2. So that's why we're able to receive the 10 network, as you can see down here. And if we do a show IP route now in router 2, we can see that we're learning to that RIP route. So if I do a ping, as you can see, we have reachability. However, on router 1, if I do a show IP route, we are not learning of router 2's loopback. And that's because, again, here on router 2, sorry about that, guys. I don't know if you heard that or not. But if you did, I apologize. Don't know what happened there. But again here, what we were talking about, right, why router 1 is not seeing router 2's loopback is because if we do a show IP protocol, you can see here that it's only sending and receiving version 2. So router 1 is running and it's sending version 1 packets, because you can see here again, broadcast out fast Ethernet 00. So out's in router 1, it's sending these updates. However, router 1 is not able to receive these because you can see here it says illegal version. So let's go ahead and make router 2 version 2. Oops. Guess I need to put in the version here. Version 2. And what we should see here any minute is with an update, we should receive the 20 network. And there we have it. Receive version 2 update from, that's router 2, and it's seeing the 20 network now from router 2. So if I do a show IP route on router 1 now, we see the RIP learned route in router 1's routing table. We can go ahead and try to ping it, 20.0.0.1, and we have reachability. So far in this lab we've looked at multicast updates with RIP version 2. By default, again, that's version 2, RIP version 2's default. It's going to update via 224.0.0.9. And we also we also looked at version 1. We ran version 1 on router 2 and we could see updates going to broadcasts. Updates sent out via broadcast, all 225s, or 255s, I'm sorry. So let's go ahead and take a look at this last type here. Let's take a look at Unicast. Let's just do this. Let's just do a no router RIP on both routers here. Let's kill the process, start all over. That's the easiest way to get rid of everything. I do a show IP route now on router 1. We don't see the RIP learned route from router 2, and router 2 should see the same thing here. Show IP protocols now. We don't have any protocols running. Same thing on router 1, so we should be good to go now. So let's go ahead and get back in here and we'll show you guys the Unicast RIP version 2 update type. And now what we want to do by default, again, if we're sending updates, it's either going to be what we saw here. RIP version 2 is going to be using multicast. RIP version 1 is going to be using broadcast. Now, if you don't want broadcast or multicast traffic being, sending updates using broadcast or multicast, you can send updates using Unicast. And the first thing we want to do here is we'll go ahead and put in version 2 again. We'll do no auto summary. So let's go into router 2 to do the same thing. So version 2, no auto summary. Now what we're going to do here is we're going to, let's see. Before we advertise the network, we'll go ahead and do the command passive interface. Again, what the passive interface command is going to do, you can look at my previous RIP version 2 labs. I think it's either lab 4 or 3 that I have, goes over passive interface. And what the passive interface is going to do is it's going to allow updates in an interface that has passive interface on it, but it's not going to send those updates out. So let's go ahead and do a no passive interface here. Actually, let's do this. No passive interface, fast Ethernet 00. That's our connection to router 1. So router 1, same thing. No passive interface, fast Ethernet 00. That's our connection to router 2. And so let's go ahead and put in the network command here for our neighbor here. I'm sorry, not our neighbor, but the network we're running. So as you can see here, we're sending requests out, fast Ethernet 00. Again, with passive interface, we're still going to send updates out. I'm sorry, we're not going to send updates out. We're going to, hold on a second, sending request on fast. Why did I do no passive interface? You know, I apologize, guys. I didn't mean to do no passive. I meant to do passive interface. Fast Ethernet 00. That's why I got tricked up here when I saw sending the request out. With passive interface enabled, we should not be sending out updates. However, we're still able to receive updates on this interface, so I apologize for that. We'll just go ahead and do a passive interface, fast Ethernet 00. Go ahead and put the network command here. And now what you see is absolutely nothing. And that is because even though we have advertised the network into RIP, we are not sending these updates out this interface in which the network is being run on. Again, fast Ethernet 00 on both routers encompasses the 192.168.12.0 network. Both of their fast Ethernet 00 interfaces. So, as you can see here with this running, there's nothing being sent out at all. So if we do a show IP route, we don't have anything in a routing table for RIP. Show IP protocols, we're not even able to see our neighbor. And let's just make sure if we do a show debug here, we do have RIP protocol debugging on. Again on router 2, show debug. Same, nope. Let's do debug IP RIP. Okay. So now, as you can see here, nothing is going on. No broadcast, no multicast updates or anything being sent across here because we suppressed all, outgoing updates using the passive interface command. Now what I'm going to show you here is our last mode in which we can transport updates, send updates to our neighbors, and that's via the Unicast option. Let's go back into RIP here. Now we do this with the neighbor command. So we'll go ahead and do a neighbor on router 1. So we're going to point to our neighbor here. So 192.168.12.2. So what we should see here is that we are now seeing unicasted traffic. Unicasted, I just made up a new word. I'm sorry. Unicast traffic is now being sent specifically to router 2 using the neighbor command. So 192.168.12.2. So we're sending version 2 updates to 192.168.12.2, which is unicast IP address. Let's go ahead on router 2 and do the same thing. As you can see here, if I do a show IP route, show IP protocol, still not seeing a neighbor on router 2. If I do a show IP protocol on router 1, same thing. Let's go to router 2 now and enable it, the neighbor pointing back towards router 1. So neighbor is going to be router 1's IP address, which is 192.168.12.1. And let's see what happens here. Alright, so if I do a show IP protocols, let's see, show IP route, let's do this. Let's go back to router 2 here. What I forgot to do is, let's take the neighbor statement off of router 2. So we're only going to have a one-way neighbor pointing from router 1 to router 2. And let's go into router 1 here, and we'll advertise the... Okay, so here we go with the... We're sending updates out. What we need to do here is we're going to put in our network statement for our loopback. So 10.0.0.0. I'm sorry. I'm going to get into RIP mode here. 10.0.0.0. And now what you can see here on router 2 is we're receiving the 10 network. So if I do a show IP route on router 2, you can see that we have it in our routing table. So if I do a ping 10.0.0.1, we have reachability. Again, you can see that we are receiving this Unicast and sending it Unicast. So you can see that we're in a Unicast update environment here with RIP version 2 now, strictly Unicast. And so now let's go ahead on router 2. Let's do a show run, pipe to begin, RIP. Same thing on router 1. As you can see here, we have the passive interface on the fast Ethernet. We have the network statement. And we have also on router 1, we are also using the neighbor statement to unicast the traffic back to router 1. I'm sorry, from router 1 to router 2. So let's go here and on router 2, let's go ahead and advertise our loopback 0 interface into RIP. So we'll go ahead and do a router RIP and then network 20.0.0.0. And now what you can see here is that when we have router 2 set up to send the 20 network, you can see here that it's sending it only on the loopback 0 interface, because it's not allowing, with the neighbor statement and the passive interface, it's not going to allow this traffic across to router 1. If we go to router 1 and take a look here, we do a show IP route, you can see here that we're not learning into that network via router 2. So as you can see, it has to be bidirectional, or else you're going to run into routing problems here. So we also have to have the neighbor statement on router 2 pointing back to router 1. So we'll go ahead and go on here and do a neighbor 192.168.12.1. And now what we should see here on router 1, as soon as I do this, are in a couple seconds, we should see, again, we verify show IP route, nothing there, show IP protocol, nothing there, show IP route, nothing in the routing table. Let's go ahead and do this neighbor command. And there you go. There you have it. 20 network is now being advertised to router 1. And it's sending these updates via Unicast straight to router 1's IP address on that fast Ethernet 00 link. So again, this is the Unicast RIP version 2 update. That's how we're sending updates via RIP version 2 is Unicast right now. And we can see that in our debugs here. If I do a show IP route on router 1, we can now see the RIP route from router 2. We can go ahead and try to ping it here. Ping.20.0.0.1. We have reachability. And before we exit this lab or quit this lab, I'm going to show you one last thing and that would be if you ever get tasked to advertise a network into RIP without doing redistribution or anything else like that, and you can't use the network command. Let's go into router 1. Let's just create a loopback 11. Let's do IP address 11.11.11.11/24. So say we have this loopback 11 IP on router 1. Loopback 11 is 11.11.11.0/24. So say we need to advertise this network into RIP, but we cannot use the network command. We're not allowed to redistribute connected, into RIP. So no redistribution, no network command. How are we going to get this into RIP? Well, there's a way to do this, and if you go under the interface here, if we go into router 1, if I do a show IP protocols, you can see that we're only routing for networks 10 and 192. Now if I go ahead and on router 1, if I go under the loopback in which we want, or the network in which we want to advertise into RIP, in this case a loopback 11, I can specify the command IP RIP v2 broadcast. Let's go ahead and put that command in here and see what happens. Okay, so what we can see right now, we're not seeing it, and let's just verify what's going on here. Doesn't look like it's going in. Let's do on all on router 1 here. I'm going to go ahead and pause it, and I'm going to tell you exactly what's going on in 1 second. Okay, well, I guess I was mistaken there with the IP RIPv2 broadcast command. I thought I could use that to advertise networks into RIP. However, I've done some research here, and it appears as though that is just incorrect information. I think the broadcast command is ultimately used like in the original area on in this lab where we had router 1 that was running multicast and router 2 was running broadcast. So router 2 was running legacy RIP version 1 and router 1 was running RIP version 2. I think to get those two to work together, I would just have to go to well, let's do this real fast. No router RIP on router 2, and we'll do on router 1, same thing. Let's just lab this up real fast. And then we'll go ahead back into router 2, we'll do router RIP, do no auto summary, and we'll just do network 192.168.12.0. We'll go ahead and do a do debug. And what we're going to do is go to router 1, we'll do router RIP version 2, no auto summary, and then we'll just do network 192.168.12.0. So again here with the IPRIP version 2 broadcast command, I was mistaken. For some reason I was thinking you could advertise a network into RIP using the command. I thought I had done that before in the lab, but I guess not. I guess really what it's used for here, and I apologize for misleading you, is when you have one side configured as broadcast. So in this case RIP version 2 is running, legacy RIP version, router 2 is running RIP version 1, so it's sending broadcast packets out, whereas router 1 is sending multicast out. So let's go back into router 1. We'll advertise our networks into here. So we got the 10 network on router 1, and we have the 20 network on router 2. So now, again, like we talked about earlier, we just received the 10 network from router 1 from router 2's perspective. That's because if we do a show IP protocols here, we're sending and receiving version 1, and we're also receiving version 2 updates. So that's why we're able to receive that update from router 1. However, router 2, if we do a show IP route, we're not seeing the RIP learned route from router 2, and that's because if we do a show IP protocol, we are only sending and receiving version 2. So these version 1 updates are not being received by router 1. It says here illegal version. So a way to, so if we go here into router 1, and we go under the, if we do a do show run interface fast Ethernet 00, let's go under interface fast Ethernet 00 now. If I do an IPRIP v2 broadcast, now what I should see is router 1 start sending updates using the 255 address. So that's exactly what we see here on router 1. And as you can see here, we're still seeing the illegal version, and that's because we are still running RIP version 2 on router 1, even though we are sending messages out as broadcasts, like we're acting like we're a RIP version 1 router. However, what you can see here is that we're still seeing packets coming in from router 2 saying that it's a legal version. So the way we can get around this is if we go into the interface here again under interface fast Ethernet 00 on router 1 and do a IPRIP, and now what we can do here is receive version, so we can change the version of RIP in which we receive. So IPRIP receive version 1. So now what we should see on router 1 is we should see the 20 network now from router 2 any minute here. And boom, there it is. If I do a show IP protocol, you can see now that we're sending, but we're receiving version 1. And again, RIP version 2 is running legacy RIP, which is RIP version 1, so it's sending this out as RIP version 1, and router 1 is now able to receive version 1 updates. And as we can see here in our routing table on router 1, we see the RIP route now from router 2. Let's go ahead and try to ping it, and we're good to go. So that's it, folks. That is RIP version 2 updates, we looked at Multicast, Broadcast, we also looked at Unicast, and I thought you could do RIPv2 broadcast and be able to, let's look one more time here on router 1. Show run interface loopback 11. So now we have broadcast on loopback 11. Let's see here. Still not seeing it on router 2. I don't know, guys. I thought you could do that. I guess I thought RIP was cooler than it is. I don't know. Nope, we're only seeing the /2410 network, so of course we're not seeing the 11 network. Anyway, sorry about that, guys. A little misleading information there, but we made up for it by showing you exactly what the IP RIP version 2 broadcast command is able to do. What it was able to do here is on, the last thing we did was on router 1 is we went ahead and again, it was only allowed to, bring in version 2 updates. What we did there at the end is we changed that to allow version 1 updates to come in. And again, router 2 was RIP version 1, so router 1 was then able to receive updates from router 2. And that's when we saw the 20 network in router 1's routing table. And then also, we did the IP RIP version 2 RIPv2 broadcast command under the fast Ethernet 00 on router 1, and what that was it allowed us to do is send updates using broadcast instead of multicast. Then we also looked at the neighbor statement within RIP, and we looked at how we use the passive interface with the neighbor statement to unicast packets to and from neighbors. So I hope you guys have enjoyed this video, and I'd like to thank you for watching.